Hi, this is Jennifer Telford. This week's assignment, we're talking about lactate and the whole process of which lactate goes through. So we're going to get straight into it, and we'll go into the first slide. So going right into the process which lactate goes through, we're going to go straight into the Cori cycle. So when oxygen levels are low, muscles go through the anaerobic metabolism to gain ATPs. So we're going to start over here with the muscle. We've got lactate that's being produced in that muscle, and we're going to look at the relationship between the muscle, lactate, and where it's going in through the liver. So we've got our two lactates here that are being produced in the muscles from the work that we're doing. That is then being transported through the blood and over into the liver through gluconeogenesis. So muscles convert the pyruvate into lactate using the enzyme lactate dehydrogenase. This is important to regeneration and maintain the NAD plus needed for glycolysis. So going in through here from glycolysis, taking it in through the blood, and then again we're back into gluconeogenesis. So lactate produced in the muscles is taken up by the liver where gluconeogenesis occurs. It then converts into pyruvate and then back into glucose, which then gives you ATP, glucose, and then we're going straight back into the muscles again. So this is where our energy production comes from. So basically the liver's kind of transporting it, converts it back into ATP, back into the muscles again. So that's essentially what the Cori cycle is. Let's go ahead and answer some of the questions that had to do with some of these lactate pathways. So how are lactate pathways affected by exercise intensity and training adaptations? So aerobic training adaptations that affect your lactate pathways. We have a decreased rate of lactate formation during physical activity, an increased rate of lactate clearance during physical activity, and then the combined effects of decreased lactate formation and increased removal. So essentially, if you're working at a good aerobic level and your body is training and it's adapted to it, you're going to be producing as much lactate at the same time that your body is starting to clear that lactate out. So we don't have that lactate accumulation. That's obviously an ideal way because you're not going to fatigue that way. So changes in exercise intensity affects blood lactate levels in a few ways. So during steady rate physical activity, aerobic metabolism is equal to the energy requirements. So the net result from that is very little or no blood lactate accumulation. So kind of just what I set up here in those training adaptations. That's your easy steady state stuff. During high intensity physical activity, there's an increase in hydrogen concentration from CO2 production and lactate formation. This makes the blood pH more difficult to regulate. So when those the blood pH doesn't regulate as easily, you're going to start to get that increased accumulation, which can then go into the fatigue, which I'll go into on the next slide here. So once the lactate threshold is reached and intensity and duration continue, onset blood lactation kicks in. So that's your OBLA. OBLA is when blood lactate concentration systematically increases. So the lactate threshold is going to hit at one level, and then your OBLA is going to kick in a little bit further on there. So you can still hit that lactate threshold and continue on before your onset of blood lactate kicks in. And we'll go into the next questions here. When can lactate be used metabolically, and the consequences of lactate accumulation and our ability to sustain exercise? So some of the things that we kind of touched on in the last one, I'll talk about here. So lactate is used in the body when intensity levels are near maximal and lactate production is high. So once those lactate levels are up really high, you've passed that nice, easy aerobic state, steady state that you're in, that lactate accumulation is going to increase. Lactate can be used as energy through the anaerobic pathways, thus increasing ATP resynthesis. So during training adaptations through aerobic exercise, lactate accumulation has the ability to remain low, therefore inhibits the process of muscular fatigue. So again, that's going in with as much lactate is being brought into the body, the same amount is being converted out. So lactate accumulation can cause a change in the blood pH and therefore affect acidosis, which in turn may affect the energy supply by reducing the glycolytic rate and be a cause of the muscular fatigue. So talking about that blood pH in the previous slide, this is going into the facts that the accumulation is going to go up, it's going to change that blood pH and the acidosis, and that's what's going to change that energy supply and reducing that glycolytic rate, which is what we talked about in that first Cori cycle slide, and that's going to give you that cause of muscle fatigue. So obviously, an athlete or anybody who works out and who's starting to train their body into working out for longer, you're going to push those anaerobic thresholds, those lactate thresholds. It's going to take longer to fatigue out. So those adaptations that you start to build through your training, whether it's aerobically or it's anaerobically, you're going to start to see those change. Therefore, you're going to build up your lactate threshold, and the accumulation is going to take longer before you start to fatigue out in your muscles. So hopefully that answers the questions as best as it can. And thank you very much.